Now this is problem 46 from Smith's Organic Chemistry 5th edition textbook. And we want to draw the products for each nucleophilic substitution. So, be careful when you're doing this. You don't want to draw incorrect curved arrows and reinforce some bad knowledge, but you basically want to identify the leaving group here, and then you want to snap on the nucleophile. So if the nucleophile is negative, you just connect this oxygen atom in place of that halogen. So the molecule you get for A would be, you sketch in all the carbons, and then attached to this carbon would be that oxygen atom. So you write the oxygen atom there, and then you sketch in the doubly bonded oxygen and that methyl group there, and that would be it. And that's great for the charge, okay? So if you have a negative nucleophile, it works great. Now, in this next problem B, remember that sodium is a spectator ion, so you have to write out the negative charge there, okay? So again, we are taking this iodine, which is our leaving group, and we're going to just kick it out, all right? So this is a primary alkyl halide, which undergoes SN2, so that's how I know I'm able to write that curved arrow reaction mechanism in that way. And what you get as a product is going to be, sketch out all those carbons, okay, and make sure you understand which carbon is now going to be bonded to the nitrile, okay. So that's a carbon-carbon bond forming reaction. Now, in this molecule here, iodine is indeed going to leave, but we have neutral water. You see how that's a problem? We don't have a negatively charged nucleophile. So when you do part C, you have to be familiar with the SN1 reaction, and remember that it requires deprotonation. Okay, deprotonation occurs to give you neutral alcohols at the end of the reaction. So this is going to give us a molecule that has attached to this carbon your ethyl group, and then an OH group. Okay, an OH group. So this makes alcohols. Okay. In molecule D, reaction D, we have a neutral alcohol and then a tertiary alkyl halide. This also is going to go by SN1. It's going to involve deprotonation. But this molecule is not water. This is ethanol, and this ethyl group gets carried in place of the hydrogen. So here you have a hydrogen, okay? And in reaction D, you're going to have our 5-membered ring with a methyl group, and then on that carbon you're going to have an oxygen, but you're going to have the ethyl group, okay? So I just wanted to kind of highlight that difference there. There's your ethyl, okay? So C and D are very related, okay? Alkyl halides can make alcohols or ethers. This is called an alcohol, and this functional group is called an ether, okay? This is an ester, and this is called a nitrile. In E, so what you need to do again is discard that sodium and write out the negative charge on your nucleophile, and this negative charge can attack this carbon right here. I like to put a dot on it usually, and it can kick off the halogen. So what you want to draw for this is a 6-membered ring, and go ahead and sketch in, attached to that carbon, an OCH3 group. Okay. Now, in this molecule here, we don't have a hydrogen. There's no SH, so there can't be deprotonation. Those two ethyl groups have to stay there. Now, this is going to perform an SN2 reaction because this is a primary alkyl halide, and those only undergo SN2. And what we're going to get is, if you read the curved arrows and the formalism of keeping track of the formal charge, you will have attached to this carbon not a halogen, but a sulfur. And that sulfur is bonded to two ethyl groups. It's now going to have just one lone pair of electrons, and it has a formal charge of plus. And the leaving group is going to be part of this because this is a sulfonium salt, okay? And so that's how you draw these products. These would make great reactions for flashcards. Thanks for watching.